Hi, my name is Skylar Brooks and my project is on photosynthesis. I decided to do this project because wavelengths and photosynthesis are interesting, and how plants can actually provide for themselves is, I'm more interested in it. So I was doing research on the different wavelengths and how they're effective and whatever is actually in the visible spectrum, which is really small compared to everything else that there is out there. And so plants that are in the ultraviolet rays below 100 below 200 is actually deadly to plants. And as they progressively get higher, they become more beneficial, but when they get too high, plants, all that's absorbed is converted into heat. And so
So what was your experiment? Did you do an experiment or was it research?
Mostly research.
And what was the coolest thing you found?
The coolest thing that I found was that wavelengths that are too low will immediately kill the plant, and wavelengths that are too high, all that they'll do is convert it into heat. It's a special kind of happy medium.
Cool. Okay, so I'm gonna just go to your board. Do you want to read out the different sections? Because that's what they want us to do. So your discussion,
Discussion. Various types of electromagnetic waves are essential for the growth and functioning of plants. I did this experiment because I thought that different light wavelengths would affect plant growth and photosynthesis. I found that electromagnetic waves around 600 nanometers provided the maximum benefit for plants, but anything greater than 600 nanometers were converted to heat and plants were unable to use the light source for photosynthesis.
Okay, results.
The electromagnetic waves of the shortest wavelengths, 100 nanometers to 250 nanometers, were extremely deadly to plants, and no photosynthesis were observable for the plants. Contrastingly, electromagnetic waves with the largest wavelengths, 800 nanometers and more, only provided heat to the plants, and the electromagnetic waves were not used for photosynthesis. The most optimal wavelength for plants to undergo photosynthesis were around 500 nanometers.
And materials and methods?
The following materials were used for this experiment: computer, plants, electromagnetic wave gradient. I researched the effects of electromagnetic waves on the plant's growth and photosynthesis using Google search engine, and I compared the wavelengths to the respective effects of plants.
Future directions?
In the future, it would be interesting to compare the effects of electromagnetic waves on different kinds of plants, because varying plants may react differently.
Okay, there's your works cited, and then, what is this, experimental results? So is this the graph here?
Yeah.
Did you make that graph, or is it from online?
Online.
So do you want to explain it?
Right here, 0.01 nanometers is gamma. 1 nanometer is X-ray, 100 nanometers is ultraviolet. Right here is around where the visual spectrum is. 1 millimeter is 1 centimeter is what's it called?
I don't know. I have no idea.
Infrared. And right here is radio.
Cool. Is there anything else that you want to add?
Well, you could get shots of these.
Okay. So what are these?
This is the cycle of photosynthesis. Sunlight is absorbed and it's converted from the typical plant cells, nucleus, that kind of stuff. Oxygen, water, then it's converted into food. And right here is pretty much what the results were, but in the full form.
Oh, cool. Okay, great.